So I want to start off my talk by asking everyone a question. And it's really the title of this talk. Have you ever asked yourself how the best hackers learn their craft? And by hackers, I don't mean criminals, of course, or people who break into systems without permission. By hackers, I mean people who can make computers really bend to their will. I've been fascinated with this question of how the best hackers learn their craft because really I see hacking as one of the highest levels of the creative exercise. I mean, if you think about it, how often are you trapped in a particular world or ecosystem that a vendor locks you into? My iPhone just went off, and really it's just locked me into Apple's ecosystem. And it's not just me with a phone, right? We even hear about farmers, for example, who get locked into ecosystems with their tractors. But hacking and hackers, it's really about freeing themselves from those ecosystems, about being able to show computers can do something new and something often even the developer didn't even think was possible. Something really extraordinary. Now, I spend quite a bit of time studying what I call high performance hackers. And I'm really excited to give this talk because I think there's a system that you can use to get to that level. Or more importantly, there's a system that you can use to build teams and pipelines of computer security talent, hacking talent. Before I get into that, though, I want to introduce you to some of the world's best hackers that I've had the pleasure really of knowing. So this is George Hotz. George Hotz, when he was 17, came up with the first iPhone jailbreak. You all may remember that when the iPhone was first released, it was really tethered so that it could only work with AT&T. There was nothing really hardware or software specific about it. It was just how Apple and AT&T decided to make it work. So George was able to find the first 0-day for an iPhone, and it really opened up a whole new area where iPhones were then able to be used on a variety of different systems. And George has done other things like gone out and hacked the PlayStation. He's gone out and shown 0 days for browsers and then safely disclosed how these were done so that vendors can actually improve security. Or by a hacker, I also mean people like Richard Zhu. Now, often, if you read media articles about him, he goes by the name Fluorescent. I know him as Richard because I actually recruited him when he was 17. Now, Richard plays in something called Pwn to Own. What Pwn to Own are these bug bounty programs where vendors will give you the latest version of their device or software. For example, Google may give the latest version of Chrome. And then over the course of a weekend, hackers will sit down and try to find brand new 0 days that break into that. And to me, this is kind of amazing, right? Because if you know anything about Google, this is the Bay Area, you know how big their security team is for just a single product. I believe last time I checked for Google Chrome, it's about 30 people. And so you have people like Richard who are able to sit down and in the course of the weekend demonstrate brand new 0 days, safely disclose them, and then security's improved. Or 2 years ago, actually, Tesla said, hey, if you can hack a Tesla, we'll give you the Tesla. And Richard was able to hack a Tesla. So how do they do it? How do they get this sort of level where they can take software where people put a lot of time and energy into trying to secure it, but show that you can do something new? And then how you train up people so that they themselves can get good at recognizing those vulnerabilities. That's really what this talk is about. And I talk about Richard and Fluorescence because these were actually both some of my students. I recruited Richard to CMU when he was 17. And both of them have played a part of what's called the CMU competitive hacking team. We go by the name Plaid Parliament Opponing. And we're considered actually one of the most competitive or world's best hacking teams. And the reason that I know that is because we play in something called Capture the Flag contests. So Capture the Flag contests, the ones we play in, are full spectrum attack defense, where your goal is to break into someone else, you get a point. And if someone breaks into you, you lose a point. Now, these are safe, closed networks. They're events put on by hackers for hackers. And surprisingly, they're actually something that a lot of people don't even know about. For example, if you've ever been to DEF CON, there's like 30,000 people. And you'll only find these CTF people in the very back room. But these are really the experts. These are the people who go off and do things like show, hey, I can break into a Tesla for the first time. Now, at CMU, I've built a system for identifying and training up this talent. And when I say we're one of the world's best, we've actually won 5 DEF CON championships. So we have a team full of black badges. We actually have more black badges for permanent entry to DEF CON than we can use. Our team was the top ranked US team many, many times since 2011, since founding, and actually the top ranked team in the world. And so I studied how these really professionals get to that level and what it takes to recruit them. And that's really what I want to share with you today, because I think it's something a little bit different that I see in a lot of different industry settings. But it's something that if you're really interested in this type of hacker, getting this sort of person who can really go find original new things, something that can be replicated across other organizations. And so really in this talk, this is a talk actually I gave at RSA. Today, I'm actually the CEO of a company called For All Secure. We put out a product called Mayhem. I'm not going to talk about that. I'm going to talk about how we bring up this hacking talent at Carnegie Mellon, how we built talent like Richard and George in our hacking team. And really, there's just 3 things in the 3 goals that I have. First, I want to talk about what are capture the flag contests, and more particularly, why these aren't just games. These are actually mechanisms for people to take deliberate practice. And this is super important, something that we often don't get, where we go and we want to learn a new skill. And so we get a challenge and then a little bit harder and a little bit harder. And it keeps getting harder and keeps challenging us just enough so that we get better and better. So I want to talk about how we use it for that. Second thing I want to talk about is how we actually do use it for gamifying. And this is just to keep people interested. And it turns out the way you gamify will change as people get better and better. So I'll talk about that. And then I want to talk about our system for building a hacker pipeline. So Carnegie Mellon, since 2013, as I said, has had one of the top ranked CTF teams. Our students often, when they graduate, have 7 or 8 job offers. They go and they work for places like, Google, obviously, things like Project Zero. They go build companies. George right now is doing Comma.ai. They just go do amazing things. So I want to talk about my system, because since 2013, we face this problem that every 4 years, our hacking team turns over. So the question I'm faced with, I feel, is very similar to what we face in industry, which is, look, I'm not going to have someone forever. How do I identify the right talent? How do I recruit them? And then how do I train them up, knowing that I'm going to have to turn this into a system that's continuously executed, not something I do just once. So that's what I want to talk about today. So for those of you who don't know what CTFs are, capture the flag. It's not the game that you go play out in the field. Really, it's a computer game which simply consists of really fundamentally 2 components. First, you get asked a question, and then there's a flag. And when you enter the flag, you get points. And so this is an example of a very basic beginner CTF question. And the question is, after opening a robots run panel and looking inside, this was a question we made up for high schoolers, actually. You discover a small red button behind a tangle of wires. Pressing the button lights up the robot's primary screen. It glows and quickly flashes blue, and a line of small text types outputs this particular error code. And then the question is, what is the flag? And if you're anything like me, you have no idea what this error code means. And what's interesting is the first thing that an expert thinks to do is maybe not the first thing a non-expert thinks to do. And the first thing an expert, at least myself, I think to do is Google. We actually designed this question specifically to see who would go Google the answer. And if you go Google this error code, the very first thing that'll pop up is this error code relates to a FAT file system. And so the flag is simply the word FAT. And so if you put in the answer FAT, you get points and you move up in the rankings. And so a CTF, the very beginner type, are what we call Jeopardy style. They're the precursor to these full spectrum attack defense. And the way they work is you have a set of categories. And typically, I think of, at least at CME, the 6 categories that we care about are: do people understand cryptography? Do they have basic knowledge of things like system commands? Are they able to do reverse engineering? And here we mean hardcore reverse engineering of things like x86 and embedded systems. Reverse engineering compiled Java is running a tool. It's not that hard. Network security, program exploitation, as well as forensics. And then on the Jeopardy board, just like you would think of in the game show, we have a set of challenges and they get harder the more difficult you get. So for a category like cryptography, you may start off by asking a simple question like a Caesar cipher. And then you get into things like frequency analysis. And by the end of this contest, you may be asking people more difficult question, such as suppose with RSA, you pick an exponent, you pick the exponent 3. How would you exploit that? It's called the RSA low exponent attack. And these are the sorts of problems that you actually find in practice, where you go out and you audit someone who's taken a textbook implementation of RSA and done something wrong. Low exponent is actually not an uncommon thing to do. But you'll see that we gave people a dedicated path. We've not started off by saying, okay, here's a full network and you're going to navigate the whole thing. We started off with the smallest, most minute problem we could think of and said, go solve this. And then we've incrementally made it more and more difficult. We've also given people an indicator of difficulty by showing them things like the point value. And so this way, as people move on and on, they can see themselves progressing. So this is one of the things that we do. This is essentially what the idea is when you start getting into capture the flag contest. Now, when you get into an actual timed competition, let's say one that runs over a weekend or even a full week, you'll give all the teams the same boards, and then you'll see who gets the most points. And so when I see CMU as one of the most competitive teams, I know this because we play in dozens of hacking contests where we continue to demolish people actually through this. But you can also use them, and this is the key part, after you're done with that contest, go back through it and start using it for training. Start using it and take that initial problem, and for the people who couldn't get it, teach them how to do it. Or if you're exposing just a new classroom, you can go through it and give people an amount of time to solve it and then give them a solution and then go back to another problem. Hopefully this shouldn't be surprising, but it's also something I see that's often forgotten. I was really inspired when I was watching Saul Khan from the Khan Academy talk about, in public schools, a lot of people will teach students, they'll give them a test, and then if a student fails the test, doesn't matter, you're still going to move on to the next subject. And so there's this kind of like march through the curriculum, as opposed to stopping when people have problems and keep getting them new problems until they understand the material. And that's really what CTFs are about, is coming up with lots and lots of problems, each incrementally harder. So one of the things we've done at CMU is we've run a contest called Pico CTF. We specifically have designed this for high school students. And one of the things that we've done is we've gamified learning. And so you'll see on the left a set of graphics, and we use part of CMU called ETC. If you've ever seen the last lecture, which will completely make you cry if you ever watch it, it's the same part of CMU that Randy Pausch taught. We use them to design the games. But behind that game, we've actually carefully architected a story as well as a progression of challenges. And we've used techniques that you find from game theory, like at the beginning of the level, you give people easy questions, and then they get harder and harder. And then when you get to the next level, you actually have to reset to them being a little bit easier. Otherwise, people will stop playing. And we've added these to the contest. And the whole purpose of these, I talked about how people change as they go, is by giving people this kind of gamified platform, they're not intimidated to get started. Often when you give adults a problem like the one that I just showed you, they may freeze. The same is true for kids. You don't want them to freeze. You want to make it a very easy on-ramp as far as getting people involved. Now, actually, as people become more and more experts, we provide an alternative interface. And that alternative interface actually looks something like this, where the games and the graphics disappear. And people are just now in this kind of self-perpetuating goal of getting better and better. And so when you're gamifying them, it's kind of an interesting realization that how you gamify the beginning and how you gamify for novices is different than how you gamify for experts. So when building a CTF, we actually look at three principles. The first is they should be a forum for applied deliberate practice. Sure, you can run a contest. Those contests are short-lived, but afterwards you should be able to reuse the same material to get better and better. And when I talk about practice, what I'm talking about is you're taking a particular skill and you're honing it down to the very basics, and then you're trying to get people to solve that. You're not trying to get them to solve real world problems. This isn't a performance. This is more like if you learned an instrument where they give you an etude. An etude is there specifically for you to get better at a skill, as opposed to when you play like a symphony or an actual piece. These are about deliberate practice. They're not about necessarily being real world. The second is it's a forum for people to really be autodidactic and to use this idea of self-learning to get better and better at concepts. And so one of the things I actually take pride in at Carnegie Mellon is I've been able to build this team that has consistently done well in professional hacking contests and are consistently sought out as some of the best in the world, at least at hiring time, and are somewhat legendary. I think at one point, I was talking to Rob Joyce, who now is the director of cyber at NSA. And I talked to him when he was running TAO, Tailored Access Operation. And informally, he said at one point, like TAO, like 20% of them were my students. Well, part of that is about not me going in and teaching them everything, because quite honestly, many of them are much better than I will ever be. It's about setting up a forum and the right sort of system where people get used to learning things themselves, breaking down the skill, practicing those smaller skills, and then building it up and applying it. The final thing that I want to talk about CTS in our principle is to look at creativity over rote. Now, I have a feeling in Silicon Valley, this is going to really play well. It's something you all intuitively understand. Part of hacking is understanding that the developer had a very fixed view, or the designers of the system had a very fixed view, and you have to think outside the box. And so you want to encourage that in their contest and how you teach hacking. The reason I put this specifically on the slide is I've seen people who try to run CTS and they'll go and grade how you approach the problem as opposed to whether you got the right solution. And so I'll talk a little bit about that and how you can build in this idea of creativity into CTS. So the first thing I want to talk about is this applied deliberate practice. So I gave one example of first thing we have to do is give people permission to Google and then go learn about stuff. But then we actually want them to apply that skill. We don't want an expert in just reading. We want people who can take that skill and go actually type on a keyboard and do something. And so I'll give you an anecdote. At the sophomore level at CMU, we teach people how to do a buffer overflow. I think maybe we're a minority of universities, but we actually teach people assembly at the sophomore year about how overall computer systems work. And what I found is in about 90 minutes, I can go through an entire classroom exercise and explain how a buffer overflow works. You know, at a high level, I think everyone intuitively gets it. The programmer says, okay, the user input I'm going to allow is 10 bytes, or I'm going to expect 10 bytes, and then the user input given is much bigger, like 300 bytes long. You know, it's like a shelf where you put too much weight on it and it collapses. It wasn't designed for that. And so I can really, within 90 minutes, get in deep and talk about, for example, here's a function, here's a stack frame, here's the assembly code, here's where the return address is, this is how you do conflow file hijack. And what I find is consistently, after 90 minutes, everyone walks out nodding their heads, thinking they've got it. I understand it. And then the next thing I do is I give people a very simple homework problem and say, apply this knowledge. Go, here's a very simplest buffer overflow you've ever seen, exploit it. And what's really interesting is time after time, you see these people who walked away with so much confidence that they understood it, but then didn't know how to apply it. And so that's really what CTFs allow you to do, is take the second piece of go and apply it. For example, how do you figure out in a program where you're just given the binary what the buffer size is? Often, here's another funny anecdote. They'll get it to run in GDB and then it won't work on the command line. Why is that? Oh, things like environment variables will offset the stack. There's all these sorts of details that go into actually using the tools where you're trying to marry the theory to the actual hands-on exercise and then getting to that level of mastery. And so that's what CTS really work for. And what's funny is it'll take 90 minutes to teach the basic concepts to people, but we give them a week for that first homework. Because putting theory to practice is actually kind of hard. So I want to ask you, because I heard that questions come at the end, I want to ask you to solve this, but here's a real world example. And we ask high school students who routinely solve this problem to do it. How would you go about it? So assume you're given the sequence of instructions. Push EVP, move ESP to EVP, so on and so forth, right? Well, when I put up this problem, I've actually been careful. I've given people a couple hints. First, you'll notice this is only a 5-point problem. It's just telling people that it's actually not a very difficult problem. I'm giving them a cue. The second thing is I'm giving people links to reference. So I'm saying, hey, go read about this. This isn't a textbook problem, but it's about textbook concepts. You're not going to find the solution online, but you're going to find everything you need to know, and it's actually not hard to learn. And so by going and doing this, by giving people these problems, you're saying, look, you can learn this. I know you can do it. I'm going to see if you're the type of person who will go and do it for yourself. Now, as I said, a lot of people just kind of freak out. It's funny, even in information security, people will freak out when they see this and they'll be like, I don't really know assembly. But that's where this autodidactic part comes into play. And recall, auto is self and didactic means to learn. So it's really just this idea of self-learning. A lot of people have this idea that there's going to be a professor. And when you give them that sort of problem, they're just going to teach you everything you need to know. And then after the end of that lecture, you're going to somehow be a master at the force. It's a really romantic concept that by having the best instructor, by having the right coach, that you're somehow going to become Luke Skywalker, but that's not really how it works. Really, all we are in the background is providing people a small challenge. And sometimes we may not even know how to solve that challenge exactly ourselves, but we know that it's something a student can, it's just outside their reach. And so this idea that there's this Yoda is wrong. What you want to go do is find the person who, with a little bit of encouragement, will go learn it themselves. So I can tell you, when I recruited Richard, this guy makes over $1 million a year in bug bounties this year. When he broke into a Tesla, he could break into 500,000 vehicles, I think, over the course of that weekend. He finds 0 days in Chrome. He knows exploitation up and down now. When I recruited him, he was 17. He didn't know any of this stuff. He'd only played in math Olympiads. No real computer security experience. And I put him in front of this problem. And so he read up. And him and thousands of other high school students were able to break down this problem and to come up with the answer. And so just by some simple reading, you can figure out things like, hey, there's this function name, and we're talking about a return address. So let me focus in and Google for return address and understand that. So there's a return address, it's 4 bytes. That push EVP increases your stack pointer, so that puts another 4 bytes on. And the sub increases your stack space by hex 70, 112 bytes. And so you may go in and say something like, the answer is something like 74, because it's 70 plus 4. And then, of course, you realize that answer is wrong because you put that as a flag. And then you finally realize, it says decimal. So I'm going to translate this to decimal. That's 116. And then simply by putting in 116, we can count that you've got the answer. Now, notice in all of this discussion, we've had high schoolers do this, but I haven't gone out and put out fancy videos on how to read assembly. I haven't gone out and had to lead them through classroom exercises. There's tons of internet material out there to do that. People are smart. You just got to give them an opportunity to stretch their wings. All I've given is given them an oracle on whether they're right or wrong and as much time as they need to figure it out. Which really leads me into this third thing about creativity. Hacking by its very nature is figuring out the unexpected, at least at kind of these higher tier levels. And so I love this comic strip just because I think it's funny, right? There's this idea of a self-operating napkin, and people can say that's an overly complicated machine, but honestly, it does its job. And a lot of what hacking is, what actually even distinguishes them from a developer, is their idea of making things work. And I'll also, by the way, warn you, because you're a good hacker doesn't necessarily mean you're a good developer. There's different skills you want to emphasize there. Well, when you're trying to teach these top hackers, you're trying to teach them this idea of coming up with these ingenious ways of approaching a problem. Things that people haven't expected to be possible. You have to say, well, hey, that may be the common wisdom, but somehow you have to almost suspend reality for a second and say, hey, I can figure it out. So let me talk a little bit about the solution versus the result. And this is one of the ways I've seen we differ with some other people out there on how they do things. So the problem in this was to find the flag. I gave you this problem and all you had to do is enter in 112 and then you got points. So that's the problem. So many people may think the solution is the flag like 116 here, but that's wrong. The flag is not equal to a solution. The flag is actually the result of coming up with a solution. And that's where you want to have creativity. You want to give people, I can tell you when you have a right result, but I'm not going to constrict the solution to be exactly what I think. The way I figure it out may be different than the way you figure it out. And then at the end, if you really want to maximize benefits, you share, you don't constrict. And so one of the things I love about CTFs is we just check the result. We don't check the solution. And what you find is pretty amazing things if you do this long enough, where people invent things that you didn't even think were possible. I kind of think of it in math this way. Suppose your kid was given the problem of what is 2 times 2? Well, there's many different ways that you can solve this problem and all are valid. All you want to check is whether they answered 4. If they wrote down their steps and their steps corresponded to any of these are totally valid. There's no reason to discount them. And in fact, part of hacking is trying to get people to think beyond that first solution. What are other ways you might be able to do it? So let me give you an example from actually 2012, because I found this was really interesting. So the problem was to break into a PHP-powered website made by the organizers. And the idea was this is going to be an XPath injection vulnerability, and you had to come up with the exploit. So when you're creating these sort of problems, you can kind of think of it as, hey, I'm creating this maze and I've kind of roughly checked that there's a solution. So I at least know it's solvable. And then I'm going to put it out there. And so XPath was the way we thought people were going to solve it. What was really interesting actually is when this was put up, there was a Dutch team that actually found a flaw in PHP itself and found a 0-day in the interpreter where they could go and they could exploit PHP, and then they grabbed the flag. What was even funny about this is not only were they able to get this reference or this solve this problem, this hacking contest, it turned out they had found a 0-day in the same sort of PHP engines that were running Facebook at the time. So really kind of interesting stuff out there when you allow people, and you don't want to challenge them with impossible problems. You know, you don't want this this unsolved problem mentality. You definitely want to know there's a solution. But what's interesting is sometimes people come up with solutions that you had never thought of, that even border on this idea of completely novel. Second example I'll give you is RSA. So for the purpose of this, let's just assume RSA is considered mathematically secure. We can certainly push the symbols and give you here is the fundamental hypothesis where we think RSA is equivalent to factoring, invented by these very smart people, Ron Rivest, Adi Shamir, and then Alderman. So we consider it mathematically secure, but can you hack an RSA site? Some people will just shift to the crypto. But here's the funny thing, the crypto doesn't talk at all about the software security. And this is where a hacker will focus. They'll go read about the crypto and say, hey, I understand the math, but there must be something about the implementation that I can take advantage of. Let me give you an example. Suppose my wife asked me, do I look fat in this outfit? Any sort of delay reveals information, right? It's a very dangerous question to get asked, and you better right away say, you look absolutely awesome, honey. Anything other than that is a wrong answer. The same is true in crypto. It turns out that RSA up through, I think it was 2012, and certainly if you do a textbook implementation, and this is 2012, including things like OpenSSL and even Microsoft, essentially had that same problem. If the key was 1, it took 1 second to decrypt. If the key was 2, it took 2 seconds, 3 seconds. It wasn't really seconds, but the key was strongly related to how long it took to decrypt. I worked with a guy named Dan Bonet at Stanford, and what we show is we could actually break most crypto implementations with the timing attack against RSA completely over a network. And because of that, all current implementations of RSA actually operate about 10% slower. They use something called blinding to get rid of this. But it shows you how, even before this, we thought RSA is secure, but when you look at the implementation, you realize, yes, that's the math, but the math is platonic ideals. They're abstract. Let me go and think outside the box and look for something unexpected. And because of that, we were able to break into lots of, well, we were actually able to extract the RSA key and lots of different things. So when we think about designing these CTFs, we also think very hard about the levels of proficiency. And by that, I mean, at some level, you're just trying to deal with awareness. And I'll talk about this on how we designed your system, but people will have a basic knowledge. Maybe they've read some articles or have a passing interest, but they're not really sure what hacking is. I call this almost the Reddit crowd. If you ever go to Reddit r hacking, 99% of the posts are people here who have some amount of awareness, and you're just trying to give them a taste where they feel some measure of success to lead them to the next step. Where there's a novice with limited experience, and then an intermediate who can do some amount of practical application, but probably is missing the theory. And then as you build up to those harder problems, you're starting to get into the more advanced theory. And then at some point, like when you're a Richard or you're a George, they're a recognized authority. And they're at that level, they're going to learn the most from each other. And so you should be building this in actually into your hacking challenge. So how do you, we talked a little bit about, there's this Jeopardy style, and we employ that at CMU, and that's really for the awareness to the intermediate phase. How do you change when you get to those upper levels? Well, I talked about CMU, and we play in these attack defense contests. This is what the DEF CON CTF is, and this is why it's considered the Super Bowl of hacking. If you've ever been to DEF CON, you've played in the CTF, you may not recognize the names, but as soon as you get out of that room, you'll start to recognize the people they do. You'll see like, hey, on that team over there, there's this guy who goes by the name of Gynophage. Did you know this is actually a DARPA PM who has like 1,000 different IoT vulnerabilities on his name? You don't see that in the hacking contest because he's known by Gynophage. So you're competing really at this expert level. And the way it works is everyone's given a computer and everyone runs the same software. It's really simple. You exploit others, you get a point. If you get exploited or your system goes down, you lose points. Now, when you enter into this round, it really ups the level because you can start learning from others. I'd also caution you not to employ attack defense CTFs until people reach this level. For example, if you are actually competing in DEF CON CTF, the first thing you want to, one of the things you want to do is always attack the weakest members first. Now, this may seem unsportsmanlike, but this is just how you win. And this is why I say it's advanced to expert. The reason you want to go against the weakest first is there's something called a reflection attack. If I exploit you and you're diligent in your network mining, you actually will see the exploit. Even if you get exploited, you'll realize what you've done, and then you can take that exploit and replay it against someone else. This is called a reflection attack. And actually, to be competitive at any level, one of the things you have to be able to do is a reflection attack. You have to realize that someone is going to find a 0-day you didn't know about. You have to be able to recognize that on the wire when it's used, and maybe you get exploited, but then you turn around and you can hack other people. If you're someone who does bicycling, you can think of this as drafting. If you can just reuse other people's 0 days enough and then come up with one original one, you can move into the lead. So these are the sorts of things that you start practicing when you get at that sort of level of really being an expert. And this is how you start learning from others. So what do we do at CMU? How do we get people to that level so consistently? Well, we start off at the basic level and we run a contest called Pico CTF. And this is something I started in 2013. And it really had 3 goals. Grow the cybersecurity field. So we wanted to reach a large number of people. We wanted to identify and attract the most promising high school students to CMU. And then we wanted to systematize the 2 points above so that I could repeat it year after year. And by the way, I have 0 funding for this. We actually run this contest year after year with, we're lucky enough to have a little bit of funding now, but it's mostly just scraping by. And what's funny actually is there's great companies like Hack the Box. We actually have more high school students and I think more total registered people solving problems than any of them. We have over 100,000 people on Pico CTF. And if you go to the website, you'll notice there's nothing special about it. It's just that the problems are really, really good. So in 2013, the first time we ran it, we had 10,000 people. We found this little hack ourselves on how to reach a lot of people quickly. We actually targeted teachers. We found a mailing list for different teachers in every state and emailed them and said, hey, we're going to run this hacking contest where you can learn about computer security over 5 days. So, of course, high school teachers are very excited about anything where they're given new material they can teach where they themselves don't have to present it. And so we got a large number of people enrolling. Today, if you go to Pico CTF, it's part of like the National Collegiate Cyber Scholarship. It's ran in Japan under another name and under Canada under another name. We have about 100,000 players. I have here actually a screenshot of how we use it. So we actually try to measure the number of team completions. So every team has a maximum of 5 people, and then we measure how far they get. And so you'll see things like first contact, where they're trying to do network traffic analysis. We have a number of high school students. We had the first year, 1,300 teams who were able to solve that entire level of challenges. And then as you go on, what's interesting actually to me is the number of people at the high school level who can go and find a 0 day, not find a 0, come up with a 0 day. And not just do that, but employ that something I would consider an advanced exploitation technique, return-oriented programming. So they're literally going in and doing ROP themselves. This is really like professional pen, not just professional pen tester. This is professional bug bounty, professional tailored access operation. When you give people these sort of challenges, they can actually get there. There's like, in that first year we ran this, there was 96 teams, so 96 times 5 people who are able to do this. So why do we do it this way? So our first goal is to be as open as possible, to have that game interface where as many people play as possible. And really secretly what I'm doing is I'm setting up a funnel. There are thousands of high school students that play, and I want as many of them as possible to run and play in Pico CTF. And the reason for that is if you think of marketing or you think of sports, the larger your funnel, the more advantage you can take of the law of large numbers. There's going to be those exceptional people, and it's easier to identify among a large set than a small set. You're more likely to run into them. So I also get to promote this, like free content, people like it, they love it. And what I do is for the top 10 teams, so this is 50 people, I will personally write a recommendation letter for them. And these are high school kids to college. Now, not to CMU, to any college. I'll just say, hey, I'm a professor. By the way, this person completed these challenges. This is the same curriculum that's at least at the sophomore level at Carnegie Mellon University. And it's the sort of problems where, for example, in our classes, they would get an A in that section. Now, when they apply to CMU, they get what's called a preferred status. What preferred means is just, it's not that they automatically get in, it's just they take a second look at their application, right? You pay a little bit more attention. And so a number of them actually decide to come to CMU. And then I put them through coursework and I have them play in harder and harder CTS. Pico CTF is very beginner based. And then when you get to things like Plaid CTF, those are hard problems. And then when you get to DEF CON, that's really where you work with the world's elite. The guys who built Binary Ninja, Jordan Weens, he used to be competitive at DEF CON, he no longer is. It's just gotten that hard. Now here's actually kind of the interesting secret that I put on. I told you that we have our students turn over every 4 years. If someone does choose to come to CMU, I actually recruit them, not just to the hacking team, but to build the next CTF. Now you may think this is somewhat self-serving because I'm building a system here, a cycle, where when I recruit people, I can use them to help identify the next generation. But there's also a very sound reason to do this. People who play CTFs know what good CTF problems look like, and people who don't are bad at it. One of the saddest things I've ever seen is when you go get an organization, regardless of how good they are, but they've never played a CTF, run them. And they're just terrible. So often when I see someone say, hey, I just ran a new CTF, I ask, like, what have you played before? And if they've never played anything, I know their CTF is going to be terrible. A good kind of interesting real life example of this was the presidential CTF that ran last year. The thing was awful. If you go on Twitter, you can't find anyone saying good things about it. And that's because the organizers have never played in one. And so as part of the system, we're building the funnel, but we're also getting experience. So when people start writing challenges, they understand how to build that next increment and how to give people the right hint so that it doesn't give away everything, but forces people to think and to be able to get there within the time limit we give them. So I mentioned that we have this big funnel, and as anything, when you have the law of large numbers, you essentially get a bell curve, right? You have average, and average is actually, when you look at these contests, average is higher than you would think. But what I'm really interested in is, how do we identify those exceptional people? How do we go and recruit them? And that's where I come back to being autodidactic. It's a theme that's been throughout this talk, where if you can encourage people to do this and you can see people who excel, those are going to be your 10Xers. I would rather any day of the week take someone who is autodidactic and a B student than someone who's an A student who only learns by rote. Second thing is, they have demonstrated ability. If you've been good about how you design the problems, they've actually demonstrated the abilities you care about. Now, can these people, for example, in a CTF, do we ask them to go through large code bases? No, that's real world, super important, but it's not honing it down to a little skill. What we want to do is say, okay, this is the sort of problem they were looking for, and then make it trickier and trickier to solve. So they get better and better at identifying it. And then finally, you can identify the top talent. So this entire talk really has had two themes. The first one are CTFs have been a proven effective way to teach hacking skills. When I go look at George and Richard, and I look outside of CMU, I look at how people like Jordan Weens, who builds Binary Ninja, a fabulous reverse engineering tool, get good. They will, without hesitation, say CTFs. When I go look at how do you use these, what we find consistently year after year is because we built the system of identifying talent to exposing a broader and broader set to hacking. And we've been very thoughtful about having easy problems and leading people along this path and doing so. We're able to maintain that system over years, like 8 years now. It's pretty hard to do anything in computer security for 8 years at some sort of top level. We've been pretty successful. The second thing I want to talk about is you can actually systematize this to build your pipeline. It does require an investment. You have to think about it. You have to put these principles into practice. You have to go find people who have played, but if you do it right and treat it like as seriously as you would treat building a marketing funnel, you can really build an awesome pipeline that at some point becomes hands-off. It's just a machine that just keeps running even when you're out. Now I'm proof of that. I mentioned I'm CEO for All Secure. I've been away from CMU for 3 years. The last time we won DEF CON was 3 years ago, actually, after I'd taken a leave, and we've gotten second place the last 2 years. We've done really, really well. This team has been able to take Pico CTF and self-perpetuate the system. They've been able to teach themselves and get each other to that high level consistently, even when I'm gone. And that to me is success. When you as a manager don't have to manage anymore. So I always like to end talks with, what is actions that you can take? So the first thing is to incorporate CTFs into your training. I'm a big believer of it. I think a lot of people go and they look at things like, hey, I'm going to go take this test or get this certification. To me, if someone does well in CTFs, then I actually have a ranking of them against everyone else. I have comparables. I think it's a great way to build into the training, and it's a great way for you to assess ability. The second is to try to use these sort of things to build a system for identifying talent. For example, when someone applies for an engineering position, it's not uncommon, or it wasn't before the drought of engineers we have, to give them a small problem and see if they could code it, right? FizzBang, I think, is the test that we often use. You can do the same thing in cybersecurity, where you can give people a very small problem and say, hey, I know, because I've given this to other people, that this should really take about 30 minutes to solve, and see how people do it. It's really illustrative. And if you get really good at this, you can start taking advantage of the law of large numbers. To do so, you have to make sure you're building with good problems. And again, I encourage you to go to Pico CTF. The UI is almost embarrassing sometimes, but in some ways that shows where our attention is being put. We're focusing on building good problems as opposed to fancy graphics. And too many, I guess, managers in security focus on, okay, I want this huge center and it looks like cyber war games where all these things going across. No, that's not important. What's important are you building problems that are interesting and that you can demonstrate people are slowly acquiring skills over, etudes, if you will. And then you can use these even internally to identify and train talent. So I'll stop there. And I do want to mention a few credits. A lot of the concepts I'm talking about are ones that I've learned. They're not things that just I discovered. I just try to codify them in this presentation. Tyler Niswander was a student of mine, went on to become the captain of PPP, the hacking team, and then has done amazing things in practice. A lot of these ideas really, actually, he was really good at solidifying. Peter Chapman was my first student who helped me put together Pico CTF. First time you run a contest is painful. So I have to give him a lot of props. And then Megan Kearns, who runs it today, Pico CTF, and the PPP team. And finally, I want to thank Jordan Weens. So Jordan Weens, he CEO of Vector 35, built Binary Ninja, but he was actually my motivation for putting together a high school hacking contest. He was going out there and running these for high school students himself. And I said, hey, why don't I just build a platform that tries to reach more? And so the way, I kind of happened upon the system. I didn't go in saying, I'm going to build this huge funnel and then recruit. It was more coming from this place of, hey, I think it's important to teach high school students, that was inspired by him. So I do want to give credit to those people and then open it up for questions. And I'm going to stop screen sharing just so I can look at you guys.
All right, I'll turn my camera back on. We don't have any questions in the queue right now, but one of the questions that I have is and I've already answered this for myself, but from a practical standpoint, for say a small organization, where do you see the CTF fitting in, and how could I use that in my smaller organization
And
to identify talent and that sort of thing?
So we use it in a couple different, or I've used it in a couple different ways. So one is, when you get into this community, generally this community is by just natural selection, higher talent. So if you go and start getting into it yourself, you can identify kind of that community. Second way actually that we use it is I will point people at existing problems. So I didn't put them together, but I've solved them myself, and use those during recruiting. For example, someone says, hey, I know exploitation. I'll go and I'll throw out micro corruption. It's a free website. I didn't put it together. And I'll say, hey, in the interview, how would you go about solving this? I don't expect them to solve it, but it's just kind of walking through the challenge. And the reason I like doing that is A, I didn't have to put together the problem from scratch. B, it's on the web, so it's easy to share. C, I know it's solvable. And I usually have some idea about how hard it should be. And so, like micro corruption, I love micro corruption, right? It's a super easy architecture. I see all these people who say, I know exploitation. And then I try to really understand, when you say exploitation, do you mean like running Metasploit or coming up with a 0-day? And, this is kind of an acid test. Kind of the same thing as, what is it called? The fizz bang pop test for programmers, where you give them a very simple problem. And like 99% of the people who say they can program in that language totally fail it. Not 99, but it's an interesting thing in some ways, where I hate to say it, but there's kind of an indication of a lemon market. So typically when demand outstrips quantity, you end up with a lemon market. And when you look at IT in general, we kind of have all those characteristics, which means we can't be quite necessarily as discerning as we like. And so it's really kind of an interesting acid test.
So, if you don't mind, I'll put out one of the times that I've actually used a CTF. It was part of our security awareness training program at a small company. We had about 500 people, only about 150 of our engineers in our Bangalore office, but we had a capture the flag event where we ran one of these downloadable prepackaged CTFs that we modified slightly. And we then identified some security champions within the organization, within the engineering community of our organization, to say, hey, come work with us so that we can make our products better.
Exactly, like Hack the Box and things like that. Putting them on for your company is a fabulous idea. And I go back to this example of Richard Zhu, who's like this guy who he's like 23 years old now. He's far younger than I am, making far more money than me. And he'd never done hacking. He'd done math. He just has an aptitude. And what you'll find are these people, and you're like, hey, why don't you come over and work for me?